So we're going to look at the notes for Earth's interior. And my apologies, we've always in the past done activities to kind of get you to the point where you learn the information by doing the activities. And I think we try to stick with that. And for e-learners at home especially, and then even our students here at school, because we're not doing as much discussion with the material, I think some students found it difficult to really get all the material when they go to do the activities. So I think from here on out, we'll switch things up, and I'll put the notes link in the week so that you can have access to them. And then we'll go over the notes once we've done the activities. So let's look at the Earth's interior. The first year, we're talking about geology. And geology isn't just rocks. I know that a lot of times when you hear the word geology, you think rocks. But it's the study of the Earth. So it's people, geologists are people who are studying the forces that are making and continually to shape the Earth. So geology is the study of the Earth, the inside of the Earth, the surface of the Earth. And geologists are scientists who study the forces that are making the Earth and shaping the Earth. There are processes that are going on now that are giving us clues as to what things might have been like and how the Earth may have formed. When we're looking at surface changes, these are forces down inside the Earth that can change the surface. So we have two different types. We'll first start out with constructive forces. If you think of the word construct or construction, you're thinking about building, like construction companies build things. If you're constructing something out of Legos, you're building it. So constructive forces are shaping the surface by building up things like mountains, volcanoes, land masses. And destructive forces, the base where they're destroy or to tear apart, to wear down. So these are forces that are slowly wearing away mountains and features on the surface. So if you look at weathering and erosion, you can see the pictures here. You see forces that are breaking down and wearing away. If we look at how the Earth formed, now there are different theories to this, and I'm certainly not telling you which theory you need to believe. But if you look at an old age scientific theory of how the Earth formed, again, they're theories, nobody was there, so we don't know for sure. But according to an old age scientific theory, the Earth formed from a big cloud of gas and dust, what's called a solar nebula, that collapsed into this spinning disk because of gravity. Things with mass have gravity, so the more mass, the more gravity, and the gravity starts to pull things towards the center. So the center of this is very dense, very hot, which is what formed the sun. Your rock and metal particles that are denser and heavier clumped together to form what are called planetesimals. The bigger they got, the more gravity they had. So more mass, more gravity, and then the more material was attracted. They call that accretion as it attracts together. And then they call these protoplanets, kind of like baby planets. We talked a lot about density last week, and density is going to cause those heavier metals and elements like the iron and the nickel, and even like your radioactive elements to sink down towards the center, or gravity pulls those down. And then the less dense kind of, quote, floated, for lack of a better word, up to the top. So you can kind of look at the animation and see the heavier sinks. So those are your metals that make up the core. And then your less dense elements kind of float out. And then they form layers based on these densities. This just kind of gives you a sequence to go by for the Earth forming. Then we talked about seismic waves. That's where we're at this week. We're really diving into these seismic waves this week and looking at how seismic waves are used to determine the Earth's interior. So seismic waves are giving us information about the Earth. They're waves generated from an earthquake that travel through the Earth. And we're going to look at two of the main waves, the P waves, or they're called primary, and they will travel through the outer core and through the inner core, right through all layers of the Earth. The S waves cannot travel through the outer core. S waves will not go through liquids or gases, only solids. So when they leave a solid layer and enter into a liquid layer, they cannot enter that liquid layer, so they'll reflect or bounce off. If we're traveling to the center of the Earth, we'll start at the crust, and then we're going to get down through the crust anywhere from about 5 to 40 kilometers thick, and then we'll enter the mantle. Mantle is your biggest layer of the Earth, and it's nearly 3,000 kilometers thick. So at about 2,900 to 3,000 kilometers, you'll enter into the outer core, which is also a pretty thick layer, about 2,200, I think, kilometers thick. And then you get into the inner core. As you go down, the temperature is going to get hotter and hotter as you go, and the pressure will increase just because you've got all those layers and gravity pulling everything down towards the center. The heat that's in the core, so I mentioned the temperature increases the farther down you go. As you get down into the core, the heat down in the core is thought to be left over from those initial formation of the Earth. So those collisions, as those planetesimals would collide with each other, they give off an immense amount of heat. You also have some radioactive decay. So you have some elements that are radioactive in the core that are slowly decaying, and as they decay, they do give off radiation and heat. The heat that was first generated at the beginning is probably due to friction from things, those heavy elements sinking down, as well as collisions from other planetesimals. And then we have Earth's magnetic field. We mentioned this, especially if you were in school. I had a lot of questions that stemmed from the Brain Pop, a lot of I wonder questions about Earth's magnetic field. We mentioned that the outer core is thought to be liquid because the S waves don't go into it. So the heat is hot enough to melt the iron, so you have this liquid metal. And many scientists believe there are electrical currents moving in that outer core because of friction. These electrical currents, because they're moving around a solid iron core, create a magnetic field. When we do some physical science towards the end of the year, we'll learn about how you can create a magnet by putting electricity around an iron core. We call that an electromagnet. So basically, the Earth is kind of like one big giant electromagnet. The Coriolis effect causes fields to be generated in opposite directions. So you have a magnetic north and a south pole. So the Earth's magnetic field is really caused, they think, by the spinning inner core inside of that molten iron outer core. You can go ahead and use these notes to help you with your study tools, your study guide, and any activities that you need to finish up. Feel free to email me any questions that you have about anything in the notes. I'm checking email frequently and trying to get back with people as soon as possible.